Hi, this is the fifth episode of my video course about reactive programming in Angular. Sorry for the long break, I was pretty busy with some other stuff, but from now on I promise to deliver new episodes every 2 weeks, at least. So today we are going to talk about a topic called backpressure. So what is it about? Backpressure is about dealing with scenarios when an observable is producing data faster than we can consume it. It sounds maybe a bit abstract, but you will see some nice practical examples for it. And in this episode, we are going to talk about so-called lossy backpressure techniques, and we will implement in our reactive bands application a new screen where the user will be able to search for a band. So I mentioned these lossy backpressure techniques, and there is this division to lossy backpressure and lossless backpressure. So basically, when an observable is producing data too fast, you can do two things about it. You can just skip some of the data because it's not really necessary. And that's what you do when you're dealing with user events such as clicks or mouse events or things like that. But some days you have no option to lose data. You cannot skip data at all. And that's, for example, when some data is pushed to you from the server and you're observing that. And if that data is like stock market prices or something like that, you cannot really drop any of this. And there are also techniques of dealing with such scenarios. That's called lossless backpressure. We are going to look at it in the next episode. All right, so let's get to write some code. We are going to create a new component in our reactive bands application. So far we had the band list. Now we will add a new component that will allow the user to search for a band. But let me first show you some changes that I made to the band data service. That's a mock service that simulates some backend server storing some data for us. So far we had the getBands method here that returned an observable of list of bands, and now I've added a new method, searchBands, that accepts a query string and returns a list of bands that contain this query string inside its name. Cool, so let's now generate the new component. I will just use Angular CLI and generate band-search. Wait a moment. Right, I forgot about component. And generate component band-search. And now we have the new component here. So yeah, let's add the HTML file for it. Component.html. And let's change the template to template URL. That will just say band.search component HTML. Now for the HTML, I won't type it here because it will take too much time. Let me just copy paste it from my place. I had it prepared. So here, and let me explain it quickly. So what we have here, what we have here is two Bootstrap rows. The first one contains an input field, and this input field on the input event, it takes the search stream observable, or actually a subject we'll create it in a moment, and invokes next on it and passes the value of the whole field to it. So the idea is that this search stream subject is an observable that emits the content of this text field every time someone types a letter, a character. And underneath we have a unordered list which binds to the search results observable, uses the async pipe to unwrap it. So we expect the search result observable to emit arrays with results. Great, so let's now proceed to the TypeScript file with the component. So I will just create this subject that I mentioned here, search stream subject, and initialize it with a subject of string. And also, I would like to have this search result stream observable here, but it's not initialized yet, and it will emit arrays of bands. That's why its type is observable of band array. Cool. I don't need on init here, so let's get rid of that. And now what I need to do is transform this subject, which emits values provided to the text field, into this observable, which emits arrays of bands based on our mock backend service. So I need to inject the band data service here because I will be calling the search method. Great, so what I need to do now is initialize the search results stream and start with the search stream and call the pipe method on it because I will be applying some nice RxJS operators. So this is actually something we've already done, and you should be familiar with this. For each value emitted by the source observable, you'd like to go to the server, to the backend, and fetch some data, and then merge the results into a single observable. So that's exactly what we're gonna do. We're gonna import merge map, and for each query string emitted by the search stream observable, I'm gonna call this this just band data service dot search bands and pass the query string here. There is actually a shorter way to write this down because we want to pass a function to merge map. So basically I could do this because this is a function. But the problem with JavaScript is that when I do it like this, the this keyword would mean something else than this method expects it to do. So I need to do a small trick. I need to call bind with band data service on this. So I'm basically binding this keyword to band data service. And now it should behave better. It's rather subjective if this is more readable than the previous way of writing this, but it's up to you. Great, so I think we can run the app now. Let me type ng-serve here. And let's go to the browser. Oops, need this. Okay. Oh, there is one thing missing. We need to somehow display this new component here. So I will quickly extend the routing. So let's go to the app module and register a new route path. It will be called band.search. The component is obviously band search component. And now app component HTML, we need to add one new path here. So the router link is band.search. The query params, we don't need that. And let's call it search. All right. So now we have the new component here. and I can start typing. So let me also open the Google DevTools here, console. All right. So let's say I type S, and after a second I got the results from the mock backend. And now, of course, if I type slay, then I just get slayer, which is fine. But look in the console how many round trips to the server we had to make. So yeah, to make it more clear, let me get rid of that. And now let's clean the console. And now I will type slayer slowly, SELAYER. And you can see that after every single key I typed, there was a trip to the server side, which is really not very optimal, because when the user types some keyword to search for, they are only interested for the result for the keyword as a whole, and not with the partial results for for every single letter. And also another optimization we can make here, and let's actually start with that, is that we are not really so much interested in results for very short query strings, right? Because yeah, there are just 3 months in this database, but if there are like thousands, there probably many of them contain the letter S, and I don't want to display all of these results at once. So let's maybe start with this simple optimization. Let's go back to Visual Studio Code. And for that, we know all of the techniques that can be useful here. So actually what we can do is apply the filter operator to get rid of the short query strings. So I will just take the query string and only return true if its length is greater than 2. Great, let's just quickly test it. And now if I type S, nothing happens. I type L, nothing happens. And only when I type A, fetching data started. So that's something that's better. But we still have a problem here. So as I mentioned, every time I type a single letter, I make a round trip to the server. And I don't want to do this. I'm only interested in the result after the whole keyword is there. So we have a perfect situation where backpressure would be useful, because we have an observable that is producing events too fast for us. It's producing the events faster than we would like to process them, than we would like to consume them. And this is also a good candidate for lossy backpressure techniques, because I'm not interested in the intermediate results, in the intermediate events. I'm only interested in the final event. And that means that I can lose the intermediate events. That's why I can apply one of the lossy techniques. And we'll do it right now. It's actually really simple. So let's go back to Visual Studio Code. And I will just add a single operator here. It's called the bounce time. So the way it works is we can give it a number of milliseconds. And after every single event on the source stream, the operator waits for given number of milliseconds, and only if there is no another event, it will emit the original event. But as soon as there is some new event on the stream, it will just skip the previous event and it will start waiting again. So just notice how great it fits into our needs, because every time I type a single key on the keyboard. I don't really know if it's the final key or will there be more. So the best thing to do is to just wait for a short period of time, such as 500 milliseconds. And if there is a new key typed within that period, that means that the user hasn't finished typing yet. So we don't want to emit, right? And if there were no new events on the stream, that means that either the user is a very slow typer or more likely that he has finished typing, which means that we can emit the whole word and initiate the search for that. So let's just apply this new operator here. It's the bounce time with 500 milliseconds. And now we can test it. Let's go to the browser. And now I will type Slayer rather fast. So let's watch the console. Let's see what happens. SLAER. And fetching data was done only once because I typed fast enough that every next letter was typed within 500 milliseconds since the previous letter. And that's actually a good solution to this problem. That's one of the backpressure strategies in action. And just to see that if I type very slowly, like S, L, well, for this, I don't go get any round trip to the server because they are filtered out. But now I type A and there was a round trip because within 500 milliseconds, nothing happened. And then if I type YE very fast, there was just a single round trip, right? So I think it's pretty clear how the bounce time operator works. And I hope that you also see that's pretty useful because this kind of scenario with search with live results, it's pretty popular and pretty common. And RxJS offers us a great way to implement it. And also we see the power of RxJS here because doing this with RxJS is very nice, declarative and simple. And you can imagine implementing this with imperative programming would be rather a pain. There are actually some more lossy backpressure techniques such as throttling and sampling, but I think the bounce is the most useful, most practical one. That's why I decided to show this one to you. And as I mentioned, next time we're going to talk about lossless backpressure techniques. So before we finish, I'd like to ask you that if you enjoyed this course, if you think that is bringing you some value, then please subscribe. Subscribe to the YouTube channel. It really gives me motivation to work more on that course and to produce more content. And also you can visit my blog codewithstyle.info, which has a lot of interesting articles about some related topics such as JavaScript, programming in general, Angular, and functional programming as well. And also subscribe to the newsletter there. That would be really amazing and make me happy. So thank you very much and see you in the next episode.